Hi guys, today I want to take a quick look at the topic of motors. Now the type of motors that we use in class would be the likes of this yellow simple DC motor. Here's another typical one, and the one with the red top here is slightly different because there's gears inside it here, but they're all simple DC motors that run from maybe 1.5 volts, which is like a small double double A battery up to a 9-volt battery. Now the next thing I want to look at is gearbox motors, because a normal motor just spins, and pretty quickly at that, maybe hundreds of revs per minute, which is often too fast to do anything with it. So a way of slowing it down is by putting gears onto the motor, and lots of gears allow you to speed up or slow down. Often it's to slow down really is what you want the motor. So that's called a gearbox motor. There's a few different ways of doing it. That's a gear train, and that's called a worm and worm wheel. But basically it's using gears to control the speed. Now a servo motor is different to a DC motor in that a servo motor, the motor is actually inside here in this blue box tower thing here, and so is the gearbox. If you look carefully through the plastic there, you can see the gears. But a servo motor spins slowly and controlled, so it's really only used for turning a quarter or a half a turn, or to do something like a robotic arm or a car park barrier or something like that is what they're used for. And you will notice there's actually 3 wires that go to a servo motor, because one is bringing current to and taking away from the motor, and the third one then is what's called a signal wire, which can monitor where exactly the gears are, the motor is, how much it has turned. So it sends back information about what angle the arm or the gears have turned through. So guys, a few basic things really that I suppose we never think about them, or not that often anyway, is what does a motor do? So it converts electricity into rotation. Now where does the electricity come from? Well, it can be either from a battery or from the wall, the mains electricity plugged in, but it takes electricity and it gives you rotation. That's what a motor does. So where do we see motors, or where can motors be found in everyday life? Well, in the kitchen and cooking there, if you're using a blender or a juice maker or a whisk or something like that, if you're baking, we'd be familiar with it in the metalwork room. The electric motors on the lathe and on the pillar drills and the electric drills or the battery drills, they're all motors where you've got electricity giving you rotation. A washing machine has a motor. It generally turns pretty slowly, but when it's spinning then it goes really quick. And a hairdryer would often have different speeds as well there, depending on, well, they have generally, I suppose, 2 or 3 fixed speeds, so you can't adjust it to whatever you want like it is. You have to take the settings. But that's some places that you would see a motor in our normal day-to-day life. Now a key thing for engineers and designers and for everybody really is, how can you control a motor? Because it's no good to you if it's spinning like 500 or 600 revs a minute or 200 or 300 revs a minute. How can you control it to do more for you? So the on-off switch obviously is one way, so you can start it and stop it using a switch. And you can also get it to go forward and reverse, so to turn clockwise and anti-clockwise using a switch. Now you can change the directions using a device called a variable resistor. Yeah, it's like a dimmer switch, but for really accurate stuff there then, if you want to control how much a motor turns, you need a special type of motor called a servo motor, and that controls, you know, how much, like, does it only turn a quarter of a turn? So servos don't do lots of turns. It generally operates within like a quarter of a turn or a half a turn or whatever. Maybe generally it'll be like a fraction of a turn. So that's why servo motors are different. Like if you think of a car park barrier, if I was to, you know, model it here, a car park barrier generally only turns through about 90 degrees. So it goes up and back down again. So turns up 90, back down. So it's not doing full revolutions at all. It doesn't go spinning around. It just does a quarter turn. And that's the kind of stuff that servo motors are used for. So where's a servo motor used? As I just said, car park barriers, but you'll also see it on robots. Okay, because you know the way a robot, our wrist can swivel like this. So it can turn through, I suppose, I don't know, it can turn, I guess, maybe, not maybe 180 degrees, but it's got a rotation. So if you see on a robot that can, generally they're going to have lots of axis of rotation, and you'll see them used in assembly lines there in factories where they're mass producing parts for cars or computers or all that kind of stuff. So they would be typical examples of where a servo motor would be used.